Here we have AP calculus AB problem. Okay, let's go to the information. The graph of f of x equals to sine of 2x over x is given. Evaluate the limits. The first one is limit x approaches 0 f of x, and the second is limit x approaches infinity f of x. So here we have the graph for the function f of x over here, and we have the dimensions of the plane over here. That is negative 4, 4 gives the minimum value of x and the maximum value of x. That is the minimum value of x is negative 4. It's over here. The maximum value of x is over here, positive 4, and the minimum value of y is negative 1. It's over here, and the maximum value of y is just over here. So these are the dimensions we have for the plane on which we have the graph of the given function f of x. Now let's evaluate the first limit that is given in A, that is limit x approaches 0 f of x. Here the limit of x is 0, which is a finite value, and also we have the graph for the function f of x. It's over here. Okay, now in this case what we can do is we can evaluate the left side limit of 0 and right side limit of 0 from the graph of the given function f of x, and both of them must be finite and equal. Then we can say this limit exists. So in case both of them are finite and they are not equal, then we have to say limit x approaches 0, f of x does not exist. Anyways, we need to evaluate the left side limit of x approaches 0, right side limit of x approaches 0 from the graph of the given function f of x. Okay, now let me do it. First, let me evaluate the limit x approaches 0 from its left side. So I write negative sign over here. It indicates that x approaches 0 from its left side. That is the left side limit of x approaches 0. So let me write f of x over here. Actually, whenever we have the functions like f of x, or sometimes in some other math problems we have g of x, h of x, whatever it is, it represents the y coordinate on the xy plane over here. So this f of x represents y coordinate. So now in this case, what we need to consider is when x approaches 0 from its 0 is over here. When x approaches 0 from its left side, y approaches what value? When x approaches 0 from its left side, clearly y approaches 2. So it's 2 over here. So that is the left side limit of x approaches 0 for the function f of x equals to 2. That is when x approaches 0 from its left side, y approaches 2. That is a function f of x. The value of the function f of x approaches 2. Okay, now let me evaluate the right side limit of 0. That is limit x approaches 0, positive sign f of x. So here this positive sign indicates x approaches 0 from its right side. Okay, when x approaches 0 from its right side, y approaches what? Again, y approaches the same value. So look at the graph, it's going over here. Y approaches the same value 2. So it is equal to 2. So the left side limit of x approaches 0 and the right side limit of x approaches 0 for the same function f of x, we get the same value. Both of them are finite and equal. Since both these values are finite and equal, so the evaluation of this limit, that is limit x approaches 0, f of x equals to whatever value, whatever finite value we are getting for the left side limit and right side limit, it's 2. Okay, now I have evaluated the limit in A, so that is equal to 2. Okay, now let me erase the stuff and evaluate the second limit, that is in B, that is limit x approaches infinity, f of x. Okay, for this one, like when I look at the graph over here, that is when x approaches positive infinity, very large positive value, what's happening? Y approaches what? So now we don't get a clear idea from the graph over here. So now what we can do is let's evaluate this one manually, that is limit x approaches positive infinity f of x. So here it's not a finite value, it's an infinite value. If it is a finite value, we can take the left side limit and right side limit and we can check both of them are finite and equal as we have done for part A. But it's not a finite value, it's an infinite value. So in this case, let me write this stuff over here, limit x approaches positive infinity. And for f of x, we can plug in this stuff that is equal to f of x, that is sine of 2x over x. Okay, now it doesn't matter what angle measure we have over here. So always the value of the trigonometric function sine will oscillate from -1 to +1. So that is the minimum value of the trigonometric function sine is -1 and its maximum value is +1. So irrespective of the angle measure we have over here, whether we have a very large value for this angle measure or a very small value for this angle measure or even 0, whatever it is. So its minimum value is -1 and maximum value is +1. That is, its value will oscillate from -1 to +1. Let me write it in the next step. Limit x approaches infinity. So instead of writing sine to x, we can write it as a -1 less than or equal to sine of 2x less than or equal to +1. So when x approaches a very large positive value, the value of sine to x will oscillate from -1 to +1. over x. Now it is clear the value we have in numerator is going to be from -1 to +1 when x approaches a very large value, that is positive infinity. Okay, now what is the value of the denominator when x approaches positive infinity? So here we have x in denominator. So when x approaches a very large positive value, the denominator also will be a very large positive value. So now I am going to divide the value from -1 to +1 by a very large infinite positive value. So what is the value of the fraction? So clearly the value of the fraction is 0, because whenever I divide a finite value, that is from -1 to +1 by a very large positive value, so the value of this fraction will approach 0. So the evaluation of the limit in part B is equal to 0.